All right, welcome guys. Thank you everyone that joined this presentation. Today we are talking about better error handling in TypeScript with a custom result type. My name is Marcelo and I'm a software engineer here at Viprompt. So just to give you some context, the OTT or Online Tech Talks is a place where we share knowledge, we share things we have learned in our projects, new technologies that we're studying, and research things we read and thought are worth sharing with the group. Please make sure if you're watching this on YouTube that you subscribe and give it a like. There are plenty more content there, and if you enjoy watching things related to technology, it's worth following our channel. For today's agenda, we have a couple of topics. To make it a little more interesting, we're going to have a little story behind it, where we imagine that some imaginary client has a couple of features and they want us to implement. We're going to implement those features first using try-catch, and then we're going to refactor using a custom type that we'll create. We're going to talk a little bit about this type, what are the benefits of using it, and what can we do with that type that we can't use in a traditional try-catch approach. And at the end, we can have a chat, talk a little bit, and answer some questions, and we finish the presentation. So a little bit about where I saw the result type. I was studying Rust and trying out this technology. I think it's pretty interesting and many people talk well about it just because the language has some built-in things that make it safe to write like lower level code. And they have many tricks and many features in the language to do it. One of these things is the result type. It's a special type built in the language that allows you to handle errors in a way that is different from a regular try-catch approach. And if we are in a code base that uses TypeScript, both backend and frontend, we can benefit of this type by creating ourselves a version of the result type and creating like auxiliary functions to use this type and have some interesting ways of handling errors that we couldn't have using a traditional try-catch. So our service is called Awesome Data Storage Service, ADSS, and the client is requesting a couple features. They say that they need to have some seeded data that they want to start up when the system starts. They also want to avoid duplicated input. So we know that there are a couple of validations there that we need to do. And they also want to make sure that if for some reason a certain data becomes available by being deleted or expiring, they also want to make sure that they can save using that name, even though it existed before. They want to make sure that they can still use our storage service to store that data again. And now we are going to take a look at the code of an implementation that uses regular try-catch. How does that look like? So we're going to take a look at some tests, and each test here is one of the features. And we're going to have the same set of tests, both for the scenario with the try-catch and also the scenario with the result type. And we're going to see the differences. The first, most simple example is just saving a new entity. To give you some context, the entity has a name, which is a string, unique, and an age that is a value. If this value goes below zero or below zero, we consider that the entity has expired. So we can try to break this test by passing an invalid error. And since we're using this approach with a try-catch, this service, when we call the save function, throws an error immediately and doesn't really get to our test case scenarios here And the error says here, okay, it threw. It's a validation error in the constraint min, saying that the age must not be lower than 1. Let's take a look at the service. We are going to consider it a black box, but we can take a look at the implementation and just see what's going on. So, for example, that error comes from the validation. So it's probably this line where we have a DTO, which has a couple rules, like saying that the name is a string, not empty, and that the age is a number, not empty, and it has to be at least 1, so it has to be higher. So now we understand why the test broke when we passed here a negative value. But let me make this so the tests, I want the test to stop breaking. Okay, it's all green now. And the one thing that I want to mention right now in the presentation that we're going to compare later with the result type is this. The only really way we have of declaring that our save method has like throws an error is using a documentation. So like we can say that this method throws our custom type, the save failed validation exception, which is the one that we throw here in case we find a repeated value in our database. But we also return an array of validation errors. So far it seems fair. If we hover over here, we also see the same documentation. So it makes sense. It throws if we pass an invalid value. But we're going to see later that we can improve on this, considering that if we come here and remove one of these entities, we don't actually get any compilation error. Everything seems to be fine, but we forgot to add an important exception that this method returns, the save fail exception. And the question is, what if someone comes here, adds a new method, and forgets to update the documentation? Since it's not enforced by the language, it could just happen that someone forgets and someone uses that service and looks at the documentation, checks only for these errors, and we start getting like silent errors or things that are unexpected. It's going to be very difficult to debug and find out the reason for that. So that's just one thing to keep in mind. Later, we have a couple more test scenarios. The next test here is a little bit more intelligent because we get an error, and we do a couple expects to make sure that the error is the error that we ought to have. This gives an error because as the client requested this, there's some seeded data. So one of these seeded data is this duplicated, and another one is this duplicated but expired, which it's basically useless data, but we still want to test against this. So what this test does is if we send a duplicated name, which already exists in the seeded database, then we're going to get an error. And if it sends something that is correct, then the test will break. So far, so good. This next one is checking for the input, and it's expecting the error to be exactly one validation error. The instance should be the validation error, and the property should be age, and the message should be age must not be less than 1. So I think we're doing a good job, even with the try catch, to handle and test these scenarios. But now we're going to see 2 examples where the try catch is going to be limited for a couple things that we might try to do. So what we're testing here is that we are saving something with the name equal, and then we're saving again right after. And we want to make sure that it never completes, because it should fail with a save fail exception, saying that it's duplicated, the record is duplicated. But the problem is that, for example, if we uncomment this and replace the comment, the test continues to work because this line here has thrown the save validation exception. So now we don't know which one of these calls actually threw the error, and we're not testing the original scenario that we wanted, making sure that not the seeded data isn't repeated, but the new data that we added was correctly saved, and we should get an error if we try to use it again. So yeah, this is a problem, because then you start to get hidden problems, like things that we didn't expect but are happening in a way that we don't want, but the code still runs fine. It doesn't really tell you that something is wrong, even though this could be wrong. So we're going to see a way to solve this later. And there's also this problem of readability and how clear your code is. For example, here we want to check that we cannot save a name that's duplicated in the database. We should come here into this catch, and we want to delete that record, make sure it's deleted, and then save it again and make sure that it was saved. Now, of course, this is just a test with one block inside. But what happens if this is actually a controller, and we need to use a try catch, and we also need to handle the delete? So here we have this question: are we actually handling the problem with the delete? I mean, not really. If this throws, and this is an actual implementation, we want to catch this error, right? So this is okay for the test because it breaks and we need to fix it. But for an actual controller, we actually need to handle this error and give a proper message or log or do something. And the limitation that we have with the throw built in the language is that it's kind of, for Rust, it's a panic. So the application immediately needs to do something about the error. The only way we can do it is by wrapping up a new try catch. So then the question is like, do you start to nest a try catch inside of a try catch to handle multiple scenarios? We need to think if that is really an approachable way of writing the code and how readable this code is going to be. So that's enough of me bashing the try catch, and we can take a look at the alternative. How can we do it better? So most simple scenario, just for you to see in a high level, when we call the save, this new service, so now we are in a different module, and this module is using the result, is using a version of the service that instead of just returning an entity, if we see this method here, it actually returns a result type, wrapping up our entity and providing context related to which errors are being returned here. We're going to take a look at the function, and the usability changes a little bit because now we no longer have an entity. When it calls save, we have a result. We can run our expect or test validation, making sure that it's a success. We can, since this was a success, we can call expect to extract the entity here and validate that the entity has the field. So it's similar to the previous example with the try catch that we just saved, didn't handle any problems. And now we can also make the test. What happens if we put something invalid here? The error that we get is that we expected the result to be a success, but it wasn't. So it was a failure. And now the error is wrapped up in a result. So it's a different thing than we had before. And now remember that I mentioned the issue with the comments. So how do you know which kind of exception is thrown by a certain method? With the previous example that we throw, we can add a documentation and hope that the future developers remember to update it. But if we're using a result type, we can actually let the compiler decide if we're doing the right thing or not. So to me, this is pretty magical because we are returning a result type. And if we forget to add, for example, the save fail exception here, the compiler is going to complain that we're not, this doesn't match the signature of the function. So we need to go there and update. And the same is true for the parser validation exception. Your parser validation also breaks the compilation by saying that, hey, you forgot, or this doesn't match the signature that you had there. So every time you add a new exception, you are required to also update the signature here. And for anyone that hovers over your function, they can see the documentation, and in the result type, they can see all the exceptions, all the possibilities of errors that you can get, and they can handle individually for them. So that's pretty nice. I think it's a big upgrade from what we had before. Here you can see just a couple like syntax examples of checking that this was a failure, extracting the reason for the failure, and then this is our error. So instead of getting an error in the catch, which has to be a separate block from your try, here your code goes into just one straight line. I think it makes it more readable, and you do get more, in general, it makes a better experience for you to refactor this code, as you don't need to continue nesting. If you need to add a new functionality, you just continue down the same path that you're already going with the code, or create a new function. And we still have the same checks. We're testing everything. We don't get limited by this new approach. We just gain a couple more features. Here the validation error is similar. Checks that if it was an error, extracts the reason for the error, and does all the tests, same way we did before. We did also, for both of them, we created custom exceptions. So we can have one exception per service or per thing that we need. And the type check knows that they're different because the properties don't match. Here the name has a type, which is a unique occurrence of the name of the class that we have. And this is what makes the compiler break. Then we had those two scenarios where things were more problematic, and we didn't really have a way to solve with try-catch, where how do we know that we're getting a duplicated error from the second call and not the first? So now we're calling the service. We're not getting an error thrown in our face that we need to immediately handle. We're actually just getting a regular variable, just an object, and we can handle this object in any way that we want. So we can expect that the first result is a success, and we can also expect that the second result is a failure. So now we're being very precise in our test. And if we were to change this, now our test breaks, which is what we expected. The first result wasn't a success because it was duplicated by the value that was seeded. And that's going to be very interesting. In a way, this is kind of doing a lazy handle of your error, where you don't handle it immediately when it throws. You can choose to handle it later. So this is very nice. For example, if your application needs to log when an error occurs, the result type helps you with that. Because if you were to do with a try-catch that just throws, you need to wrap it in a block, then put your logger, and then return. So it's just a lot of extra levels in your function. And here, the last example is making those questions. We no longer have nesting, and we now can choose what to do with each result. We're getting a duplicated problem here, same as it had before. We make sure that we get the error, is the error that we expect. We're also testing that we can delete, and we're checking that we actually had a successful delete. And we're saving that duplicated entity, doing the same checks, but just in one block of code instead of a nested blocks of code. And here we can make the questions again and decide for ourselves if this approach is better, is it more readable, and is it going to scale if we ever need to come in here and change the behavior of something. So for example, now, if I just want to do a log here, hey, something happened in the delete. So now we can just log. And in the previous example, if you come in here, how do you log that something broke? You're actually going to have to write this try, put the deleted here, then catch with error, and let's say you console log. So okay, you do this. It's an extra 4 lines, and you can't actually extract the deleted here. So if you want to do it later, you actually need to put it in a variable here that's going to be nullable. So it's going to make your logic a lot more verbose and nested for no reason if you have an alternative. So let me just show you really quickly what is the result type, in fact, that we're using this entire presentation. This is the file. It's not too complicated. It just takes 2 generic types in its declaration, a value and a reason, which has to be an error. By default, it's a generic error, but you can specify which one or which ones you want. And the 2 possibilities of a result is for it to be a success value or for it to be a failure. And the failure also provides you the reason for why it failed. Then we have the interfaces with the types. We have the expect function, which is useful. Sometimes we use it when you don't know that the result is a success or a failure, but you are really confident that it is a success. You can just call expect to get the value and wrap it out of the result type. But that is going to throw an error. So you just need to be careful when to use it. It's generally better to just return the result type and handle it in the way that is useful for the caller of the function and not for you that's writing the service itself. So that was a lot of code, but I think the client would be happy with both solutions. They both do the things they asked. But for us to maintain this code in the future and to really make sure that things are happening the way we want, we get to choose which one we prefer. I make this comparison table, which to me appeals more to the result, being the try catch is built in the language, so that's a pro. The result has to be a custom type, so it's extra logic that we need. But with the try catch, the con is that you always have to immediately handle as soon as something is thrown. So you need to keep nesting your code. And that's the other con, which nested code is just harder to maintain by nature. If you have long functions that go into a spaghetti style, it's not very good. And a couple of things that make the result type interesting is that we can handle lazily the error. We don't need to immediately handle it. So that's an opportunity for us to log the error. It's also good if you have a non-critical process that doesn't need to halt the application, doesn't need to panic the application. It can just continue. So maybe you log the error and go on from there. You don't need to do anything special for that. Also that the flat code is easier to maintain. And also this is a really interesting thing to me, which is providing the exact set of possibilities of error classes that you expose. So it just happens that you no longer forget to update the documentation, and you can't throw something that wasn't told. For example, if you want to change something that's really lower level, and you say that you are adding a new exception, maybe the compiler will just tell you all the places that are not handling that new type. So the compiler tells you where you need to fix it, which if you didn't have it, you just add a new exception that isn't treated in other places and you never know about it. So it's always nice if we can let the compiler do the hard work for us, and we just write code in a way that the compiler likes to help us. And that was it for this presentation. If you guys want to discuss anything, have any questions, this is the time. So no.
Nice work. Nice work, Marcelo. Really, really nice.
Yeah. So we have a couple resources here if you want to check out more about Rust and about how doing it in your project in TypeScript. So if you think this is an interesting idea of how to handle errors, there are some good links there for you. And also check out the Rust language. It's really nice for us to get knowledgeable about different programming languages. Thank you.
Great.
Can I stop the recording?
Yes.
Cool.